news, scientists have found out how zebrafish regenerate their scales. Zebrafish have been reported with scales made of bone and nearby osteoblast cells that deposit minerals to these scales to form a strong armor. On this screen, you can see the regeneration just 9 days after injury. According to local sources, zebrafish have been able to regenerate their scales using ERK signaling within osteoblast cells. This signaling is activated during the first 3 days after injury to create a large pool of osteoblasts that will regrow the fish's scales, and wherever ERK goes, tissue growth follows. The details of this phenomenon are currently being studied, and we will update you with details as soon as we receive them. Now to you, Karen, for our daily forecast.
Easter for that report on the new study. Now jumping into our daily weather here in Irvine, California. Wait, hold on. Can you say that again? Our team has just been informed that ERK activity is promoting excitable trigger waves, and these waves are able to travel the entire scale in approximately 2 days. This activity is moving at a rhythmic pattern. They're calling it concentric rings, or to most, waves. Our team has just informed me that the expansion of the osteoblast tissue within each regenerating scale was not uniform, but occurred in disc or ring-like patterns. ERK isn't sent out to the whole osteoblast cell at once, but instead it is sent in waves, concentric rings, across the cell, almost like a droplet of water. Wherever ERK localizes, there is tissue growth. These rings are controlling the growth of bone in zebrafish's scales, regenerative process. When high ERK activity occurs, the ring travels across tissue, moving from one cell to another in wave motion. These waves travel across the cell even if there is ablated tissue or surgically removed tissue. The wave almost looks as if it jumps over the ablated area. We're told that these oscillations have about 3 hours of activation time and about 5 hours of inactivation time when establishing a travel front from 50 to 100 micrometers. After the 2-week-long process of regeneration, scientists have concluded that there are about 5 to 6 ERK waves in each regenerating scale. Now to you, Irene, on our daily weather report.
Thanks, Karen. Now back to the weather. If you look over here, the high for today is seems like there's more to report on. First, let's see ERK signaling activity in its first reported state. As stated before, the ERK activity occurs in waves across each cell, like ripples from a drop of water to a larger water surface. But how exactly does this all work? Well, researchers have found that inserting a KTR sensor in one of the scale cells gives accurate readings in ERK activity. This sensor accumulates in the nucleus at low levels of ERK activity and moves to the cytoplasm at high levels according to when ERK is phosphorylated. But where does the ERK activity actually come from? Well, it depends on diffusible activators and signals. For example, in this figure, FGF acts as one of the potential activators that bind to the receptors of this osteoblast to activate ERK. When ERK is detected, a positive feedback loop is generated to continuously produce more ERK and generate the spreading wave patterns we see. However, since ERK activity is produced in localized peaks, it's clear that there is some kind of inactivation phase. In this case, the activator starts a negative feedback loop, generating more ERK to induce an ERK inhibitor and decrease the ERK activity substantially. And it seems like that's all there is on the update. On to you, Alex, for our daily weather report.
Now back to the weather report. Wait, hold on. We just received a report that scale growth is confirmed to be directly correlated to ERK waves. Fibroblast growth factors, or FGF, are ligands that bind to the cell and promote ERK activity. But when researchers blocked FGF, the ERK waves also stopped and the scale stopped growing. When the FGF blockers were removed, the ERK waves resumed and the scale began to grow again. Not only this, but when ERK was switched on all at once in the cells, growth was impaired and scales grew to be deformed. This means that ERK activation by itself isn't enough for growth. It needs to be activated in the form of a traveling wave to prevent the stress of growing the whole scale at once. This is evidence that periodic waves are important for organizing tissue regeneration. Researchers believe that we can apply this knowledge to larger tissues and organs, which is very exciting to the scientific community. Scientists often question how tissue organ regeneration is coordinated across such large distances, but this scientific breakthrough may be the answer to that question. Now that we're finally done with this story, we can move on to our weather report. For umbrellas, there are mostly clear skies here at 69 degrees, with a low 9% chance of rain here in Irvine, California. What a nice day to take a walk through Aldrich Park. Now, let's head on over to our anchor, Mencher.
Thanks, Alex. Wow, everyone, this has been a hectic day. To summarize everything we've reported today, we found out that zebrafish scales regrow because of nearby osteoblast cells. These osteoblast cells multiply rapidly because of an ERK signaling pathway that is triggered 1 to 3 days after scale injury. The ERK signal is sent out in waves that start out at one point on the osteoblast and pulsate out in rings to the rest of the cell. Not only that, when the signal reaches a wound on the cell, the waves move around the wound instead of over it. The ERK signaling pathway is triggered by activation of the FGF receptor. These upstream components play critical roles in ERK activation. Well, everyone, thanks for tuning in and have a great rest of your